Okay, we began thermochemistry in the previous unit. You guys got a bit of an intro. Let's do a quick review from yesterday, and then we'll move on to today. This whole unit is titled thermochemistry. Therm means heat, and the word heat is interchangeable with the word energy. You got a lot of vocabulary yesterday. Energy is the ability to do work or produce heat. Generally, energy exists in one of two states. It's either potential, like when I hold up this marker, and then it's kinetic, where it actually moves. I asked you to slap your hands together yesterday and to rub them together really fast. That generated a lot of heat. The faster things move, generally, the more energy is produced. In the first law of thermodynamics, energy cannot be created, nor can it be destroyed. It transfers from one state of energy to another. For instance, you could go from chemical energy to electrical energy to solar energy to mechanical to kinetic. There's many different varieties of energy. But something I'll get to later is in the second law of thermodynamics, when energy is transferred from one state to another state, some of that overall energy is lost to the environment as heat. You can't not get that back. This was very important. We identified that Q is going to represent heat in your various equations that you'll get in this unit. Remember that, which way does heat flow? From what object to what object? From the warmer object to the cooler object. So if you were to fall into a frozen lake, you want to have somebody that's warm to hug you and to try and embrace you to transfer their heat to you. If you put an ice cube in a glass of water, heat will transfer from the water to the ice cube. When we measure heat, there's different units of measurement. What is the metric system unit of measurement for heat? What is that known as? Joule. What do you call 1,000 joules? A kilojoule. There's two different types of calories. I call them like little calorie, then the big calorie. The big calorie is also known as the nutritional calories, what you see in the back of nutrition labels. How many little calories make up a nutritional calorie? All right, so how many kilocalories are there in a nutritional calorie? It's 1 to 1. 1,000 little calories makes 1 kilocalorie. 1 kilocalorie is equivalent to 1 nutritional calorie. The last thing we ended with today was the relationship between these different units. What has more energy? 1 little calorie or 1 joule? 1 little calorie. 1 little calorie is equivalent to more than 4 joules. So it takes more than 4 joules to equal 1 little calorie. Okay, so now that we have that all squared away, let's do some an example here. So this will be example problem number 1. This is when you need your calculator. A breakfast cereal, orange juice, and milk might contain 230 nutritional calories. Express this number in joules. You guys have your conversions out there at your disposal. Go ahead and work it out. All right, here's what you should have done. Your known value is 230 nutritional calories. You guys do not have a conversion here at your disposal that goes from nutritional calories to joules. So you need to convert the nutritional calories to little calories. 1 nutritional calorie is equal to 1,000 little calories. That's your first conversion. Nutritional calories cancels out. Why did I want to put 1 nutritional calorie on the bottom? Why did I not put it on the top of this conversion? Arshan? You need like units to cancel out like that, so you place it on the bottom. Now, your second step will be to go from little calories to joules. You can use either one up here, everybody. Listen up. You can use either one. Your answer will be the same no matter what. So I'm going to say 1 little calorie is equal to 4.184 joules. If you put 0.2390 calories on the bottom and 1 joule on top, that is okay. All right, let me do my calculation here. 230 times 1,000 times 4.184. What did you all get? I got 962,320 joules. Let's put that in scientific notation. The decimal is technically behind the 0. Which way do we want to shift it? How many spaces? 5 times. 9.62 times 10 to the 5th joules. And if you really want to get ticky-tacky with sig figs, it would be 9.6 times 10 to the 5th joules, because 230 is 2 sig figs. That is the correct answer. All right. Okay. Well, let's talk about calories and nutrition real quick. Just throw it away. Do you guys have testing tomorrow? Yes. If you do and you walk in during this period, don't bother handing me your pass because I'm recording the lesson. Just throw it in. Happy to see you. I figure you're testing. You're sophomores. Just throw it away. All right. Some people like Dwayne "The Rock" Johnson or John Cena, they want to get really big. Their movie roles typically involve really big, bulky, muscular guys. This means that they need to be consuming more calories than they are taking in. So if you're going to be a big muscle-bound bro, you need to consume more calories than you burn. Also, individuals that tend to have extra weight, let's say they're not exactly muscular, they're kind of flabby, they're likely consuming more calories than their body is burning. So all that energy is being stored up. On the other hand, if you're a little scrawny guy, you see your ribs, you were likely burning more calories than consumed. So I have seen students of mine in high school that were skinny little sticks, and then they may stop by when they're in college, and they discovered the gym, and they discovered a meal plan, and they got really big. Well, muscle doesn't just materialize out of nothing. You have to consume food, and you want to make sure you get like good calories, not what you may have heard of as like empty calories, like donuts and stuff like that. That's not going to get the job done. But also, the amount of calories that you take in is predicated on your lifestyle. I want to look up something here for a moment, see what the average caloric intake for women first. In this country, an ideal daily intake of calories varies depending on age, metabolism, and levels of physical activity, among other things. Daily, the recommended intake is 2,000 calories a day for women and 2,500 calories for men. A pub sub, that's a chicken tender sub, I think is 2,000 calories right there. 1 pint of Ben & Jerry's ice cream, I think, gives you enough calories that you would need for an entire day. Let me find out what that is. Calories in 1 pint of Ben & Jerry's cookie dough ice cream. Oh, that's only 160. That can't be right. Let's do fish food. That was the first one I ever had. Fish food is, half a cup. So, okay. So a quarter of the pint is 280 calories. So what's 280 times 4? It's going to be more than 1,000. That's more. So more than half the calories that you need in a whole day is in one pint of Ben & Jerry's ice cream. Last thing I want to see. Let's see. Chicken tender sub Publix calories. 6 inches is 620 calories. So we're talking 1,240. So it's not your total caloric intake, but it's more than half in just one pub sub. Now, you guys, you know who Michael Phelps is, the Olympic swimmer, America. He set the record for gold medals. When he was a swimmer, he would have, you ready for this, 12,000 calories per day. The average man would get about 2,500. He would do 12,000. So that's certainly a lot more. Let's look at Dwayne Johnson. Let me look that up. Dwayne Johnson calories a day. Johnson, on the other hand, ingests 5,165 calories per day. So if you ever see his meals, it will make you throw up. The food will be coming out of your ears. The guy that plays Thor, when he's trying to get in shape to be Thor, he really has to increase his caloric intake to get all big and strong. 6,000 calories a day. He eats 5 to 6 meals a day. So muscle and stuff like that doesn't just materialize out of nothing. That's the main point I'm trying to convey to you. So when you guys, if you want to get big and bulky, like for football or sport or just in general, you gotta eat. Every college football team has a nutritionist, and he or she puts every player on a meal plan. And you have to eat when you're not hungry. You have to eat all the time. I know someone that played soccer at Louisville. She was on the girls team. And she was in high school, scrawny little girl. She goes to college, and the nutritionist would say, I want you to eat a whole pizza, 3 times a week by yourself. You guys might think, oh, that's great. Pizza is junk food. They just wanted to put the mass on her and then sculpt it into muscle. So muscle doesn't just come out of nothing. So she would eat pizzas all by herself. Now, if you were to eat a pizza all by yourself and just lay on the couch, you're going to get a little flabby. But this was a college Division I athlete for soccer. She would eat a whole pizza by herself and then go to train and then go to the weight room, and all that mass would be going to her muscles. And she was ripped. All right, let's get to something known as specific heat. .184 joules per gram per degree Celsius. This is the specific heat of water. I want to repeat how to say that unit of measurement again, everybody. 4.184 joules per gram per degree Celsius. This is a derived unit. The variable for specific heat is going to be C. C equals specific heat. This is another vocab term. Water is a very, 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 very high specific heat. In biology, in my AP bio classes, we talk about this a lot because it has a lot to do with life. We're coming along the time of the year where surfaces are going to be very, very hot. If you go to the beach, the sand is going to be very hot. The sidewalks will be hot. The streets will be hot, which, by the way, how many of you own a dog? How many of you walk your dog? Be careful at this time of the year when you're walking your dog. If the surface that you're walking him or her on is really hot, whenever I walk my dog, I'll put my hand to the ground. And if it's really hot, I know, okay, I don't want my dog to burn his feet, especially on those black asphalt streets. So I make him walk in the grass. If you guys are wearing shoes, you don't feel the heat. They're barefoot. All they have their little pads, and they can burn their feet very badly if you're not conscious of where they're walking, the temperature of the surface. What I'm getting at is things like concrete, and asphalt, and sand have very low specific heats. It does not take a whole lot of energy for their temperatures to fluctuate. But water has a very high specific heat, which means that water can absorb a lot of energy and not change. It won't change its temperature. So the actual definition, here's another term for your vocab this Friday. The specific heat of any substance is the amount of heat required to raise the temp of 1 gram of a substance, of that substance by 1 degree Celsius. So for water, it has a specific heat of 4.184 joules per gram per degree Celsius. That's really high. Other things like sand, I think is like 0.23. Concrete, I think is 0.9. Those low numbers, which are not even up to 1, that means that you hardly have to expose those substances to heat in order for their own temperature to change. But for water, it takes a lot of heat to cause the temperature of water to change, to fluctuate up or down. Now, I know this is a chemistry class, but I want to explain to you why this is so important for biology, because some of you are going to be taking AP Bio next year, and this is really important to know. When it comes to biology, what is the majority of life on this planet made out of? Well, yeah, but what molecule? Water. We're mostly made of water. 2/3 of our body is water. You have blood, you have cerebral spinal fluid, your tissues, your sweat. We are mostly made of water. Whenever you stand up like this and everything just kind of goes like, whoa. You ever had that feeling? You're dehydrated. You need to drink some water. That's called postural hypotension. Postural means you're standing up. Hypo means not enough. Tension means pressure. You have low blood pressure. You need to drink some water. That's why everything just went black. When I'm sitting up here by about 6 period, if I haven't had a drink of water, I get a crazy headache. All I have to do is drink some water because my body's having trouble pumping blood because there's hardly any content in the blood because blood is mostly water. I need to put some water back in my blood and circulation will get back to normal. Well, in biology, here's why specific heat is so important. Regardless of how temps change in an environment, internal temp in organisms is minimally affected. In the desert, you will see the most wide range of temperatures on the earth. At night, temperatures can be near freezing. During the day, the temperatures can be some of the hottest on earth. There are life forms, both plant and animal, bacteria, fungi, that live in the desert. They are able to survive this wide range of temperatures because despite the fact that the environment is going from really hot to super cold, all these life forms are made of water. and water will not fluctuate as wildly. Here's another example I tell my AP Bio students. This summer, I'm sure you guys will go to the beach. Let's say that you jump out of your car, you're barefoot. You're in the parking lot. You put your feet on the asphalt. Ouch, 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 that asphalt's really hot. You run over to the concrete sidewalk. Ouch, the concrete sidewalk's really, really hot. You're finally onto the beach. The sand is really, really, really hot. You walk in the water, feels nice. But that sand, the concrete, the asphalt, and the water are underneath the same sun. So what gives? They all have differing specific heats. Concrete, asphalt, and sand have very low specific heat. This means that their temperatures will fluctuate, which is very minimal energy. Water will not fluctuate with minimal energy because it can absorb a lot of heat. That's the key to its high specific heat. Arshan, you have your hand up. What's up?
So calories are based on the specific heat of water.
Yes. Okay. So every substance has its own specific heat. And while I have my other computer open, I want to look up the specific heat of sand, asphalt, and concrete. Specific heat capacity of sand. See if I find a decent chart here. Let's see. Okay, here's one. Steel. I don't know about you guys, but you've been on a playground before, I'm sure. The playgrounds that you were at on elementary school, what were the slides made out of? Plastic or steel? Plastic. You know why? You guys are about 15 years younger than I am. 15 or 20 years younger than I am. When I was a kid, the slides were made out of steel. It was like the surface of the sun. You get to the top of the slide and it just goes, the slide will look like this. You know, nowadays you guys have slides where it's a little loop-de-loop. But way in the 90s, you climb up the steps and then there's a slide that goes like that. This was steel. It will burn you. Steel has a heat capacity, a specific heat of 0.466. So it took hardly any solar energy at all for that steel to heat up, and you would go down there and it would just burn you. It was horrible. Yeah.
So specific heat, does that mean it can make cold quickly too?
Yeah. It resists fluctuations to change. Huh? Colby. Let me see if I want to find sand. Let's actually do concrete. The specific heat of concrete, yeah, I knew it. It was like 0.2 something. It's really crappy. See if I can find asphalt. No. Trust, I think they're all below 1. All right, let's get back to it. Blah, blah, blah. Let's do calculating heat absorbed. Now, the cool thing with water being able to absorb heat without changing is, I remember my high school bio teacher would tell me this. When you guys drive, most cars now have an internal thermometer where you can tell the air temperature outside. If you get closer to the beach, the temperature is actually going to get cooler. And I think I have a weather map somewhere on my, yeah, here it is. Perfect. So check this out. I'm going to share this with you. This was a few weeks ago. This is from Channel 13. I want you to imagine that you live in Winter Haven. Winter Haven is right, I can't write on it. Winter Haven is over there in Polk County. See it? 92 degrees. Let's say you're going to drive to Clearwater. What's the temperature in Clearwater? 85. The reason why that is because the water in the Gulf of Mexico is absorbing heat during the day. So it is always cooler on the coastline. Look at the inland areas, 92 degrees. Sebring, 92. Wauchula, 92. Lakeland, 90. But then you go closer to the coast, that heat is being absorbed by the water. And so it's always going to be slightly cooler along the coast. Now that's during the day. Here's what happens at night. That's at night. What's the temperature in Winter Haven? 48. What's the temperature in St. Petersburg? 52. All that heat that was absorbed during the day is released at night. So during this winter time, when we have maybe 1 or 2 really, really, really cold nights, they say bring in your pets, bring in your potted plants, you don't want to get killed. You never see Pinellas County or the coastal areas of Pasco or Hillsborough or Manatee under a freeze warning, because all that heat that was absorbed by the Gulf of Mexico during the day is released at night. So during the day, it's a heat sink, and at night, it's a heat source. A heat sink means it's taking in the heat, and at night, it's releasing that heat. That's all because of water's high specific heat. So it's always cooler along the coastline. Little fun fact. Okay, so your new equation when it comes to calculating heat, we have Q equals C times M times delta T. See if you can identify what these variables stand for. Now, you will have to rearrange these algebraically if you're trying to find one of them. It's not going to be that hard, but let's identify what each variable stands for. What do you think delta T stands for? Delta stands for change and T stands for temp. Do you know how you find the change in temperature? You have to do final minus initial. Your final temperature minus your initial temperature. M stands for mass. And this is going to be measured in grams. Oh, by the way, temperature is going to be in Celsius. Forgot to say that. C is going to be the specific heat. And what is Q? Just heat. What is heat measured in? Joules. What is specific heat measured in? You guys remember how to say it? Joules per gram. You say, when you don't say times C, you say per degree Celsius. Okay? So there is your formula, giving you the keys to the castle here. God, I can't help but think about how painful those slides were. It sucked. And plastic, think about it, you guys are on those slides where it's all covered. You know, it's like a big tube, like a water slide at Adventure Island. There's a reason for that. So the inside wouldn't get all cooked. This thing was just out in the open. Oh, it's painful. Like kids would get second-degree burns on the back of their thighs. It was bad. All right, so let's see. Let me rewrite this equation real easy. I just want to be sure that you all can understand what's going on here. Let's say that we had our values for Q, M, and delta T, but we didn't have our value for X. How do you isolate that? What would you do? Think of all of you have graduated from algebra, so tell me, how would you isolate C so you could find it? Kevin?
Divide Q by M and delta T.
You would divide M and delta T on both sides. And so now you have C by itself. Good. I just want to be sure you guys remember that. It's just simple algebra. You divide both sides. Okay, so I'm going to give you an actual practice problem. And for those of you that walked in late today due to your test, that's fine. This is all on YouTube, or will be on YouTube in a little bit, and you can watch it at your leisure. All right, here we go. Example problem number 2. This is going to be on calculating heat. In the construction of bridges and skyscrapers, Max, gaps must be left between adjoining steel beams to allow for the expansion and contraction of the metal due to heating and cooling, period. Have any of you ever put chicken nuggets or a pizza in the oven on a pan, and then like midway through the cooking, you hear this loud dung? You ever hear that? That's because the metal is shifting. Heating and cooling can actually cause metal to expand and contract. And so engineers have to account for that when they're making buildings. So especially here in Florida, when it gets really hot, if you don't give the metal room to expand, it can actually break into maybe the concrete, crack the concrete, and that could cause major problems. So engineers have to account for what type of metal are we using? How much can that expand? How much heat can it absorb? So being an engineer, you have to know a lot of chemistry. And you have to know how every different type of steel or metal can expand and contract when exposed to different environments. Building towers in Florida is very different than building towers in New York. And it's very different than building towers in Canada. We all have different climates, different heat, and how much heat there is throughout the day. And I'll actually tell you guys the fun little story that some engineers goofed up on here in Tampa and in Las Vegas when we're done with this problem. The temperature of a sample of iron with a mass of 10.0 grams changed from 50.4 degrees Celsius to 25.0 degrees Celsius with a release of 114 joules. What is the specific heat of iron? Okay, so I want to help you with this. I want us to identify our known values. I'll help you guys set it up, but then you're going to solve on your own. There are 4 variables in the equation I provided you. So how many variables do you think that you will be given on every occasion? You will be given 3. So let's go through this. Raise your hand if you can read this and identify what a known value is. Look at the equation for calculating heat. Kevin?
10 grams of iron.
All right, he has 10 grams. What variable is that? That is M. M equals 10.0 grams. Very good. What else have we got? Arshan? The change in temperature goes from 50.4 to 25.0. So Arshan, before you just tell me what it is, how do you find the delta T? Delta T equals final minus initial. And so what is that? Negative 25.4 degrees Celsius. Okay, good. And what is the third variable that we are provided here? David? You have Q, which is 114 joules. Very good. So what variable are we trying to find here? It says in the last sentence, you need to find the specific heat. What is the specific heat of iron. So that's going to be C equals, tell me again, someone but Arshan. What do you call, how do you say the unit of measurement for specific heat? Derek? Joules per gram. You say, I'm going to clear it up for you. You say per. Joules per gram per degree Celsius. You don't say times. You don't say by. Joules per gram per degree Celsius. All right. So, everybody, your equation looks like this. What variable do you need to isolate? Isolate C. So what would you do? Divide both sides by mass times change in temp. Yeah. You could say it's going down by 114, or you could say it's negative 114. All right, or whatever it's going to be. All right, so here we go, guys. Let's fill in the variables. Q, we're going to put 114 joules on top. M, we're going to put 10.0 grams there. And we're going to put negative 25.4 there. Please do the math. I'm counting on you to get it right because my calculator is out of reach right now. What do you got? You should have negative 0.449 joules per gram per degree Celsius.
Would it be negative 114 on top to make the specific heat positive? Yeah. How would specific heat be negative?
Yeah, you're right. Let me get that. Yep, 0.449. You want to show your work? Let's do that. And then 114. You'd have 0.449 joules per gram per degree Celsius. All right. What I would do with you guys is, I know you can't see this, but I will provide this to you if you can look up here at me. See this chart? Everybody see this? I would provide this to you, and let's say I didn't say it was iron. I said it was some mystery metal. You would have to look at this chart and identify, okay, 0.449. Oh, that's iron. You would have to identify it like this. So the fact that the answer is 0.449 indicates that that substance is iron. If the answer was 1.825, it would be beryllium according to this chart that I'm holding in my hand. All right, we're finished with section 1.